Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to be discussing about the brain tumor detections using YOLOv10 custom object detection. So let's have a look at demo application. So this is our demo applications. So if I select here images by clicking on here, let's select this one. You can also drag and drop the images from here. Otherwise, you can also taking these images using your webcam. So if I select here the submit button, I'm clicking here the submit button, and now inside these sections you can see brain tumor is detected. So let's clear on here and let's select here another images, and let's select this one. And if I click here to open, and our image is loaded also, and if I click here to submit, then you can see one thing is brain tumor also detected and also eye is detected. That's mean here it can detect the brain tumor and also the eyes. So this is how the application look like, and in this video we are trying to building this one using YOLOv10. So बिना किसी डर के हर हर महादेव बोल के start करते हैं detail. Congratulations to the YOLO users who use the YOLO to detect the objects, because YOLO recently launched their version number 10 called YOLOv10. And if I go on here, this is the research paper of the YOLOv10. You can also rating this research paper for gaining some knowledge. And this is a full GitHub repository for the YOLOv10. If I go down, you can see this is a graph for the YOLOv10 to the recent update. Okay. And then if I go down, you can see the performance for the YOLOv10. They're actually giving me some performance based on the COCO dataset, which one having some more than 80 classes. So for the object detections, and those are the model actually generated by the YOLOv10s, and how can you installing the YOLOv10s on your virtual environment, or this is a demo, or you can checking for the validations, for the training, okay, for the predictions they're actually giving to us. Yes, you can also using here the export button, export options for building the Android applications using the YOLOv10s, because end-to-end OnX is also supported on the YOLOv10. So using this one, you can also building the Android applications. Now in this one, you're going to using this GitHub repository and try to building one custom of the detections for brain tumor detection dataset. Okay, so let's go on here and try to checking the how the dataset look like. So for creating the brain tumor detections, you will use the dataset from the RoboFlow. So you can also collect the data from the medical or hospital and try to annotate it manually. But in here, RoboFlow, they actually do it already. So we can use in this dataset. If I go inside this image sections, and you can see it having all of the images, it's nothing but more than 1,000 images. And if I go inside this dataset, it has some latest version of the dataset, which was updated on the May 27, 2023. Okay, so you can also using this version number 3 also for actually building here this custom object detection model. So now what I can do, I am simply going to download it. Otherwise, we can also using here the RoboFlow library using the API, and we can call it in our Google Colab also. Okay, so now what I can do, if I go inside this overview sections, and inside that you can see here one URL. So here you have the author name. Author name is nothing but called brain underscore or slash hyphen MRI, and also having the name of the authors. Okay, this is the workshop name. Okay, sorry, it's not the author name, workshop name, and this is the author name. So using this one, we can actually fetching this data from our RoboFlow website, and after that we can use it, okay, in our YOLOv10 custom object detections. Okay, so if I wanted to call in this data set, just download the data set using the Google Colab. So what I need to do, I just need to create one account on the RoboFlow, and after that in the API sections, I can get one API. So using this API, I can simply calling the workshop, my data set from a RoboFlow, and download it in our Google Colab. So simply I can using this data set to training here our custom YOLOv10 object detection model. So now what I can do, I'm simply go on my Google Colab. So this is my Google Colab. So now what I can do, first I'm going to changing this name. So let's changing this name. Let's call brain tumor detection. And after that, you need to also do one setting. Just click on the runtime and change runtime type should be in the GPU mode, and click on save. It will connecting with my T4 GPU. Not mine, Google Colab. It's nothing but the Google property. So our GPU is connected. So now it's time to do the coding part here. But before that, just make your hand dirty. Okay, so let's go on the GitHub repository for the YOLOv10 and just click on this code sections and copy this URL, this HTTPS sections. Okay, now let's go on here again, and after that I need to installing all of the dependency which is required in order to building here the custom object detection model using YOLOv10. So let's using here pip install and simply going to using here q and using here the git pause this one. Okay, and shift enter. Okay, so it will installing, installing all the dependency which one is inside the YOLOv10 GitHub repository. Okay, so if I go on this folder sections, then you can see in this section you can see one sample folder, and inside that you can also see here one /q, and inside is it having the YOLOv10 model also. Okay, so it will take time for installing the dependency. Okay, and also we are trying to building here, we're going to downloading here the YOLOv10 model. So if I go inside the GitHub repository, and if I go down, and you can see here it having some models available, just like YOLOv10 and then YOLOv10s, YOLOv10m, YOLOv10b, YOLOv10l, YOLOv10x. Okay, so also you can see the task size, size of your images, and also how many parameter it have, the flop, the AP value, and also the latency. So for these cases, we're simply going to using the first one called the YOLOv10n. So for that, what I need to do, I just need to go on here, and after that I need to using here the wget. Okay, and using here the p, and simply going to using here the q, and after that I need to giving here the link of the YOLOv10n. Okay, so what I can do, I just need to go on here my notepad, because I already copied the URL, so I am simply going to pass it here. Okay, so after that, shift enter. So now it will downloading this YOLOv10n model in our this repository. Okay, if I refresh on here, and you can see .q, and inside that you can see the YOLOv10n. Okay, well, so you can see our YOLOv10 installation is also done in our Google Colab file. So now what I can do, I am simply going to now download the dataset from my RuboFlow. Okay, my RuboFlow website. So for that, I'm installing the RuboFlow library. So let's say pip install. Okay, pip install q RuboFlow. Okay, I just going to installing it in my same folder called -q. Inside these sections, I am simply going to downloading here my RuboFlow library, dependency. Now what I can do, I'm simply going to import it. So let's say from RuboFlow, and I'm going to importing here the RuboFlow. Well, now after that, what I can do, I simply going to creating one instance of the RuboFlow. So RuboFlow, and inside that I need to giving here my API key. So let's say API underscore key, and inside that I need to giving here my API key. So let's giving here my API key. So what I can do, I need to go on here. So let's go on here on the setting sections, and I'm simply going to copy this one, and after that I am simply going to pass it here. Okay, so yeah, here is it, my API key is pasted. So let's assign the variable called rf. Well, now I am simply going to getting my data set using my workshop and also the author ID. Okay, so for that I can using here rf dot workspace. Okay, workspace, and inside this workspace, what I need to do, I just need to giving here my workspace name. So my workspace name is Brain MRI, and also the MRIRSKCU. I just need to copy this one, and what I can do, I'm simply going to pass it here. Okay, pass it here. But before that, I need to also getting here my workspace name and also the project name. So Brain MRI is nothing but my workspace name, and MRIRSKCU is nothing but my project name. So let's say make it project, and inside this project, I need to passing here my project name. So this is my project name. So cut it out and paste it here. You can also upload here your own data set in your RuboFlow. Okay, by your author name, your workspace name, and using also your project name. Otherwise, you can also manually collect the data from the hospital or the medical store, and you can annotate it using a label me exe file. The label me, it's having one label me Windows file. Using this one, you can also do the annotations for the YOLOv10 custom object detection model. Okay, so now what I can do, this is our project. So what I can do, let's make it project. Okay, and after that I am simply going to downloading my project version. So let's say project project.version. Which version you're going to installing? So we see the latest version of the project. This project latest version is nothing but available number 3. I hope so. Yeah, number 3. So version 3 is available. It's updated in the June 24 2023, and first was updated in the May 27 2023. The version number 1, version number 2, and version number 3. So what I can do, I am simply going to giving here version number 3, because this is the latest one. And now I am simply going to let's say make it inside a folder called version. Now I am simply going to download the dataset. So let's say dataset equal to version dot download. Okay, download. And after that I can download it based on the YOLOv10 or YOLOv8. I hope so YOLOv8 is also uploaded in the dataset, and YOLOv10 is recent. So what I can do, I'm simply going to download the YOLOv8 version, because the dataset is most likely the same for all of the YOLOv cases right after the YOLOv10. So what I can do, I'm simply going to download the YOLOv8 version also. Okay, so now shift enter. So it will download the dataset from my workspace and try to store it inside the sections. Okay, now using this dataset, what I can do is simply going to do the detection part. Yeah, also training part also, but before that I need to solve the training, right? Okay, then what I can do now we need to train it. But let's refresh on here. Now you can see here our data set. Okay, MRI3. Well, now it's time to training here. Training it using the YOLOv10. Quite easy, right? So if I go on here, MRI3, and if I go into this data.yml file, just click on here. Just I need to do some changes on that. So what I can do, the changes, I need to go on this train, and I need to copy these images, copy path, and just I need to changing on here. Okay, and also go on the billet, and just I need to copy this images path. Okay, just this kind of changes I needed in our data.yml, because using this data.yml we can access the dataset and also draw the training part here. Okay, now what I can do is save it. Okay, we can use the Control S. See, it having two classes, brain tumor and also the eyes. Brain tumor and also eyes. That means it can detect the brain tumor and as well as the eyes. Cool. So now what I can do, I am simply going to do the training part here. So for that I can using here the this one, let's say YOLO. Then I can using here my tax is nothing but my train. Tax is nothing but my detect. Detect. Okay, and mode is nothing but my train mode. That's giving here the epochs. So epochs. Okay, epoch is nothing but, let's say 25. Let's giving the bash size. So my bash is nothing but, let's say 32. If I try to make in a float, so let's say floats equal to, let's make it true. Okay, let's go on the next line. Let's say model is nothing but my YOLOv10, this one. So I'm going to copy this one, and what I can do, I can paste it inside the quotations, and let's also go for the next one. Okay, now let's the data. So our data is coming for my data.yml. So this is my data.yml. So that's why we do the changing on here, otherwise it will giving you error. Okay, so now inside that I'm simply going to pass it here. Now if I using the shift enter, and you're starting the training part here. Okay, syntax error. So syntax swap, so error. So make it true. Okay, it should be this one. That's why this error. So now let's shift enter again. Okay, so as a human being thoda mistake to ho jata hai. So it will take time, just like 5 to 10 minutes for training the model. Okay, so you can see it starting the training model and also downloading the YOLOv8. I mean, simply loading here the YOLOv10 and model. So for that, it actually requires the PyTorch. If you just want to do the same thing using your own local machine, so your requirement should be like that. Let's say Python 3.8. I mean up 3.8. Your Python version should be the up then 3.8 up to 3.8, and also your PyTorch version is nothing but 1.8 up to, okay, up to 1.8 with the coda. Okay, so in my case, in my local system, it don't have it because I have the PyTorch version of 1.7, and in my machine I can run it locally. But yeah, alternatives also support in my cases. So if I opening this my terminal and try to clicking here the Python, and you can see this my Python version. Yes, Python version is okay, but my torch version is not okay. So if I using a torch, and it will installing, and it's not installing, it will doing the torch here. Okay, and you can also check in the torch version. If my torch version is greater than 1.8, I can simply using this one YOLOv10 model in my local machines. So I can also creating here the web application using Flask or Glue. But in these cases, I need to just using the Google Colab in order to creating the web applications. So for that, we can using the Gradio library. So let's say torch dot underscore version. Yeah, that you can see we have the torch version called 1.7.0 plus Coda 10.1. So I can running this model file inside my local machine. I mean this PC, which one actually recording here. So for this case, if you have the greater version, I mean if you have the more advanced types of PC, I mean leftover desktop, so you have the Python version greater than 1.8, you can simply run it in your local machine. You can also do this training part also in your Jupyter notebook also. But because I'm poor, so that's why I'm using the Google Colab. Okay. So you can see our training is just like 4 epochs. So I'll back right after when the 25 epoch is done, because you need to also creating the web applications using the Gradio library, right? So our training part is completed. So let's closing this one. So now what I can do, I am simply going to testing it out using my validation dataset. So let's say from Ultralytics. So Ultralytics, I'm going to importing here the YOLOv10. So let's say YOLO, okay, that should be the capital. So YOLO B10. Well, okay, imported. So now let's giving the model path. So let's give me the model path. Okay, so my model path is inside my run. So if I see inside my detect and train, it having my model path. Yeah, train, and inside this wait, I have my model path. So I'm going to copy the best one. So copy path, and I'm simply going to pass it here. Okay, that's my model path. Now this is my custom model path, and now let's pass it inside my YOLOv10. So let's say YOLOv10, and inside that, what I can do, YOLOv should be the small. It's not a capital. Okay, then I'm simply going to pass my model path. Model path. Fine. Now let's use here the validation data set for the result. So what I can do, I'm simply going to pass here my source is nothing but my validation path. So what I can do, I'm simply go on my data set, and this is my validations, and I'm simply going to copy the images. Okay, and after that, I'm simply going to pass it here. Okay, well, now after that, I need to giving him a confidence score. So that's the confidence score, just like 2.5, 0.25%, my 25% of the confidence score. And let's make in the save equal to true so that I can plot it out. Okay, we can plot it out. Yeah, that's fine. Yeah, it's better we can store it inside one variable called result so that you can plot it. Okay, so let's save it inside the result. Okay, well, so this is the images, and it also testing it out in our validation data set. Well, so our result is completed, and you can see it will predict it in our validation data set, which are having 151 images. So it will store it inside my detect underscore predict folder. So if I go inside my run and go on the detect and go on the predict 2, and this are the images. So if I select here, I mean clicking on this button, clicking on these images, and you can see here the images we detected brain tumor. If I see this one this one also quite good, it will detect it. Okay, some of them is not detected if you don't have the brain tumor. So let's close all of the tabs. So now what I can do, I'm simply going to plotting here for stand of the images, just like a subplot in the matplotlib. So for that, I need to using the globe, because I need to also taking the images from my predict 2 folder. So for that, I'm going to importing here the globe, then also import it. It's the matplotlib .pyplot as plt, and also I'm going to importing here the mp image. Let's say import matplotlib image image as np image. Fine, cool. Well, from matplotlib.pyplot as plt, okay, not from, it should be the import, and import matplotlib image as an mp image. Well, now what I can do, I'm simply going to taking all of the image from my predict folder. So let's say globe.globe, and inside that I am simply going to copy this run. Otherwise, if I go into this runs and inside this detect, I have the predict 2, I can copy this path. Okay, and I can simply going to pass it here. Okay, so inside this predict 2 folder, what I can do, I just need to getting all of the images. So that's why I'm using the star. So which one is extension is starting about JPEG. I am simply going to taking all the images. So let's make it images. So images. So now what I can do, I'm simply going to display the 10 images. So for that, let's say create one variable called images to display. Let's make it, let's say first 10 images should be displayed from the images. Okay, from the images. So let's make it images. So now what I can do, I am simply going to creating one axis for subplot. Let's say plt.subplot. Okay, subplots, and inside that I can passing here 2,5 and also giving here the fixed size. So fixed size is nothing but let's say 20,10. Okay, 20,10. Well, so this is my fixed size. So let's assign the two variable called fig and the axis. If you don't know about the matplotlib, you can also follow here my matplotlib crash course, which one is available in my YouTube channel. Also, you can just follow the matplotlib and try to check that how I can create a subplot. Well, now what I can do, I'm simply going to enumerate all the value with the axis. Okay, let's say enumerate. Okay, and inside that, what I can do, I'm simply going to passing here my axis in the from the flat. Okay, from the flat, because it having 2 and 5, that's mean it having the 2 column and 5 row. Okay, fine. Now inside that I need to checking that if the I is less than equal to length of the image to display, because it having the 10 images. So let's say images to display. Okay, then what I can do, I can simply going to show the images. So let's say mp image dot im read, and I am simply going to read it based on my index number. So let's say index number. Fine. Now what I can do, I am simply going to store it inside a variable called image, and let's show it using the plt.show and also imShow. Let's using the ax.imShow first, and inside that I'm going to passing my image. We can also making the axis should be the true false. So let's say x.axis equal to off. Okay, I can passing here like just off. And otherwise what I can do, otherwise we can just making the axis equal to off if it is not loaded. Okay, if it is not loaded, you can making the axis should be off. Okay, now what I can do, you can simply go into using the title layout so that you don't have any space. So let's say plt dot title layout, and after that you can using the plt dot show. Fine. So let's show it now and just run it here, and let's see for images, I mean how the images look like for the detections. Okay, so it is loading the 10 images from a directory. Okay, here you go, it's loaded. Yeah, here you go, you can see it's loaded. So this is how the images look like. It's not detected because you don't have any brain tumor. Okay, you can see how the images look like: brain tumor, brain tumor, brain tumor. You can also download this one, just saving these images. Okay, it's like that. So now what I can do, I'm simply going to do it for the one-to-one. I mean, so that we can just, if I give here one images, just one images, it can give me the prediction for the one images also. Okay, so what I can do, I am simply going to using here the model.predict. So let's say model.predict, and inside then I have to giving the path of that, I mean my source. So let's say source is nothing but my images. So if I go inside my MRI3, and let's taking one images from the here. So let's taking one images. So let's taking the first images, copy path, and I'm going to paste it here. Just my model. Now what I can do, I am simply going to use here the result of the first index. So I am simply going to plot it here. So I need to also store it inside the result, just like we can store it inside my validation also. So result and dot plot. Well, now let's use here the annotated image. Okay, so what I can do for annotating the image, I can using here the bounding boxes. So annotated images. So from that I can using the row, all of the column, then the last axis, so -1. Yeah, so I can simply going to shift enter. Well, now you can see the images with the detections. You can see brain tumor. The detection also, you can see the numpy array, I mean the size of the array is nothing but 6403. You can also giving here your size, or otherwise you can also giving the confidence score. So what I can do, you can using here the image size. So imgsj is nothing but let's say 6040. You can initialize it also. Let's also giving the confidence. So conf equal to let's say 0.25 and 25% of the confidence. Well, so now what I can do, you can using this formula technique to creating here the Gradle applications. So for that, I need to also installing this library called Gradio. So let's say pip install Gradio. Okay, well, so it is installing this library called Gradio. So now what I can do, I am simply going to creating the interface for the Gradio. Let's import it. Let's say import Gradio as gr. Okay, it's installing this library, but before that I also import it here. Okay, no problem. Let's importing here the cp2 also, because you need to also loading here the images. So also importing here the alternative. Yeah, I don't need think that alternative is needed right now, because you already have the model file in a folder call in a variable called model. So I don't need to actually use import it here the alternatives. Okay, I can import in here the numpy s and p. Fine. Now let's creating here one function called predict, which one taking one image. Okay, I don't think that cbt is also needed. Yeah, because in these cases cbt is not also needed, but some of the elu cases you need the cbt for loading the images. So what I can do, I am simply going to copy this one, just copy this one, and I can simply going to paste it here. Okay, paste it here, and later I'm simply going to returning here the annotations images. Okay, so what I can do, I can copy this one and let's paste it here again, and I'm simply going to return it here. Let's say return the annotated image. Yeah, cbt is also not needed. Okay, now what I can do, I am simply going to create an interface. So let's say app equal to gr.interface. Okay, interface, and inside that I can creating one function called predict. I simply going to call it here. Okay, predict, and inside the input, so inside this input, so I can take the input using the Gradio library. So let's see, inputs equal to gr.image. Okay, image, and inside that I can using the type is nothing but called numpy. Okay, numpy image from the numpy, and let's creating here a label equal to, let's say, upload an image. So let's upload an image. Fine, let's do the same thing for the output also. Copy this one, and this is for the output. So let's say outputs. Okay, fine. So type is equal to numpy and label is equal to detected objects. Detect, let's say detect brain tumor on images. Okay, let's play between brain tumor. That's it. Okay, now you can also give here on title. So let's say title equal to brain tumor detection using YOLOv10. So YOLOv10. That's it. You can also giving her descriptions. So let's say descriptions. Let's say upload an image, and the YOLOv10 model will detect and annotate brain tumor. Like that. Okay, fine. Okay, so now what I can do, I am simply going to run it. So for that, what I can do, and it also launch the application. Let's say app.launch. Okay, that's it. So let's make it U should be capital so that it look good. So shift enter. Okay, that's having mistake. I need to also passing her source as images that I'm not passing it here. So I can pass it just like that. The source is coming from the here. So that's the image. Source equal to image. Yeah, here we go. And we got here an image called gr.image. Inputs equal to gr.image. Equal to type equal numpy, label equal to this one. Yeah, I need to giving him comma, and also here I go, and here you go. Yeah, I need to also giving the comma. Otherwise, it will give me the error. Okay, so now the application is loaded. Yeah, collab node detected. Yeah, the application loaded. You can all click on here and just wait for a few seconds. The application is trying to loading it on here in the Gradio library. So let's see on the loading sections. Yeah, the application is loading. Okay, so now what I can do, I'm simply going to click on here, and let's select these images and click on open. And if I click it to submit, and inside this section you can see brain tumor and also eye is detected. Yeah, so this is how the application look like and how it is actually working. So you can also clicking here to opening your webcam and taking the images, and also you can upload the file. Okay, let's select here another images. So let's select here, let's select this one. Okay, now let's click on submit, and you can see brain tumor is detected. So this is how you can using the YOLOv10 for the custom object detections. So that's it for today now, and hope you enjoyed this tutorial, and make sure to subscribe to the channels and don't forget to hit the bell icon. So I'll be back with another tutorial. So till then, take care and bye bye.